This is a video for the first day of learning how to do complex fractions. We're going to start with just a basic example with just numbers, no algebra, just to lay the concept out for you. What makes them complex is that both the numerator and denominator have fractions in them. So there's fractions inside of fractions, basically. So how do we simplify something like this? There's actually two techniques. We're going to really just focus on the first technique. I think tomorrow's lesson I will bring up the second technique. You can decide if you just want to stick with this one, and that's fine. But I do want to show you both. But today we'll just stick with the first one. The first one is to simplify a complex fraction. We're going to simplify the numerator, simplify the denominator, and then basically do it as a division problem. So in other words, we're going to treat this as if this is a problem by itself. What's a half plus a third? And then we're going to do this by itself. And then we'll have one fraction in the numerator, one fraction in the denominator, and then do a division problem. Okay, so that breaks it down into steps that we already know how to do. So we're going to start with the numerator, 1/2 plus 1/3. Common denominator is 6. So I'm going to do turn this into 3/6 and 2/6. Adds up to a total of 5/6. In the denominator, I have 1/4 plus 2/3. Common denominator between these is 12. So I'll turn 1/4 into 3/12. The equivalent fraction for 2/3 would be 8/12, giving me a total of 11 over the common denominator of 12. Again, do not add the denominators. We're only adding numerators when we add and subtract. So I have 5/6 divided by 11/12. How do I divide? Well, what we're looking at is a division problem that looks something like this. So 5/6 divided by 11/12. The other way I could write that is 5/6 divided by 11/12. And we know when we divide, we multiply by the reciprocal. Well, since we're writing it in this form, it's the same thing. I'm going to take 5/6 and I'm going to multiply it by the reciprocal of this, which would be 12 over 11. There is a shortcut. Mr. Stitt likes to use this. You'll see this next year where he puts these two together and these two together. When you're doing complex fractions, and he calls them A, B, C, D. A and D go together in the numerator. B and C go together in the denominator. So A and D go together. B and C go together. And there you go. A and D, B and C. Now I can multiply these and make this 60 over 66 and reduce that, but I think it's easier to reduce first if we can. So it's 12 divided by 6 reduces to 2 over 1. 5 times 2 is 10. 1 times 11 is 11. This becomes 10/11. So this whole expression simplifies into 10 over 11. Okay. Let's take a look at the first algebra problem. We're going to start pretty simple. We'll do ones with binomials tomorrow. For today, we're just going to stick with monomials. So, and everything's 1, just keeping it pretty easy with just denominators with x. So I have a fraction problem up here, fraction problem down here. So we're just going to start with the numerator. In the numerator, I have 1 over x minus 1. So the common denominator between x and, well, nothing would be x. So 1 over x, and I'm going to take 1 and give it an equivalent fraction. Multiply top and bottom by x. So now they have a common denominator, and 1 is x over x, which is anything divided by itself is 1. So that's equivalent. So what I end up with is 1 minus x in the numerator over the common denominator of x. Now let's come down here. Same thing, 1 minus this, so I need a common denominator of x squared. So I'm going to give this an x squared over x squared. So this gets multiplied by x squared on top and bottom. Now I know you don't see a denominator, but you know it's an unseen 1. 1 is equivalent to something divided by itself, or x squared over x squared. So now I have a common denominator. I have x squared minus 1 in the numerator, x squared in the denominator as the common denominator. So here's my complex fraction simplified into 2 fractions instead of 4 parts. And I'm going to multiply by the reciprocal. So I'll take this top fraction and I'm going to multiply by the reciprocal of the denominator. Or A and D go together, B and C go together. So I have A and D together, B and C together. All right, so what can we simplify here? Well, there's a couple of things. First of all, I see the denominator has a conjugate rule, so I'm going to factor that x plus 1, x minus 1. I also see that 1 minus x and x minus 1 could be the same if I flip this around by taking out a negative. So we're going to use that shortcut to take out a negative. So what I have is I threw the negative out in front. So it's a negative x minus 1 now. And now I see several things cancel. X minus 1's cancel. And this x would cancel with one of these x's. So you see the x minus 1's canceling. X squared is the same as x times x. So one of the x's cancels. So I'm left with a negative in the numerator and x in the denominator and x plus 1. So it looked like this as a final answer. I do want to do one more example with you real quick. Just to sketch through it real quick. This is not in the note sheet. I just wanted to show this. And I'm just going to throw some numbers down. We're going to do 3 over x plus 2 over x squared. And we'll go 5 over x squared minus 7 over, let's say, x to the 4th. Now there's a lot of similarities here, but again, it's more than just a 1. Each of them has a denominator. So I'm going to do the numerator first. To get these to be the same, I multiply top and bottom by x. So multiply top and bottom by x. So what I have is 3x plus 2 in the numerator over x squared is the common denominator. Down here, x squared next to the 4th. Well, this needs 2 more x's, or another x squared, to make 4 x's in both. So this would be 5x squared minus 7 over x to the 4th. And then we're going to multiply by the reciprocal. So we'll put 3x plus 2 over x squared, and we'll do the reciprocal of this. So that means x to the 4th is in the numerator, x squared, 5x squared minus 7 is in the denominator. And so what would simplify? Well, 2 of these x's would cancel with 2 of those, leaving x squared here. So I'd have 3x plus 2, and sometimes they don't factor cancel any more than just one thing simplifying. And we can leave it like that, or we can distribute the x squared in. Okay? Make sure you get on and do the practice.